The question is, when 3.06 gram of solid NH4HS is introduced in a 2-liter evacuated vessel at 27 degrees Celsius, 30% of the solid decomposes into gaseous ammonia and hydrogen sulfide. Calculate Kc and Kp for the reaction at 27 degrees Celsius. What would happen to the equilibrium when more solid NH4HS is introduced into the flask? So basically, the equilibrium is NH4HS, which is our solid, is getting decomposed into NH3 gas plus H2S gas. So initially we have say N0 moles for NH4HS and none of the NH3 and H2S are present in the vessel, and at equilibrium, if alpha is the degree of dissociation of NH4HS, then at equilibrium our moles for NH4HS will become N0 1 minus alpha, and the corresponding moles for NH3 will become N0 alpha, and for H2S it will be N0 alpha. So our equilibrium so let us calculate N0 first. So our N0, which is the initial moles for NH4HS taken, will be equal to 3.06, where 3.06 is the mass of NH4HS taken and the molar mass of NH4HS, which is 51. So it will be equal to 0.06 mole. So we can now write Kc is equal to concentration of NH3 into concentration of H2S, and concentration or we can say active mass for NH4HS is 1, because for solids active mass is taken as unity. So on substituting the values, we will be getting Kc equal to concentration of NH3 will be moles upon volume. So moles will be N0 alpha. Here also we are given alpha equal to 30%, that means 0.3. Alpha equal to 30%, which is equal to 0.3. It is also given basically because we are given that 30% of the solid decomposes. So our Kc will be equal to N0 alpha upon V into N0 alpha upon V. So on plugging the values of N0 alpha and V, we will get Kc equal to 0.06 into 0.3 divided by 2 whole square, and on solving our Kc comes out to be 8.1 into 10 raised to the power minus 5 molar square. Now we need to calculate Kp. So Kp is given as Kc RT raised to the power delta Ng, where delta Ng is the difference in the stoichiometric coefficients for products and stoichiometric coefficients for reactants, provided that product and reactants that we are taking in calculation of delta Ng are gaseous. Okay, so here our stoichiometric coefficient for product will be 1 plus 1, 1 for NH3 and 1 for H2S minus 0, because NH4HS is solid. So it will be equal to 2 basically. Also our temperature given is 27 degrees Celsius, which is 300 Kelvin, and our Kc is given, which is equal to 8.1 into 10 raised to the power minus 5 molar square. So on substituting these values, we will get our Kp equals to Kc, which is 8.1 into 10 raised to the power minus 5 into RT. R is 8.314 into T is 300 Kelvin, delta n raised to the power delta n, which is 2. So on calculating, we will get the value of Kp. Basically, we need to put here the value of R as 0.0821 because our Kc is in the units of mole per liter basically. So we will be using 0.0821. So our Kp comes out in the units of ATM square basically. Okay. So our Kp will be equal to 4.9 into 10 raised to the power minus 2 ATM square. Now, in the variant of the question, we have to answer that what would happen to the equilibrium when more solid NH4HS is introduced into the flask. So, since in the expression for reaction coefficient, which is QC equals to concentration of NH3 into concentration of H2S, we have no term designating the concentration of the NH4HS. So, since our QC, which is the reaction coefficient, is not changing and it is basically equal to Kc at equilibrium, so our equilibrium will not change whether we introduce more NH4HS or not. So, we can write nothing will happen to the equilibrium. And what's the reason for this thing? The reason being that is our active mass for NH4HS is 1. So this completes the answer of the question. I hope that I made myself clear. Thanks for watching. Have a nice day.
Hello, the given question is that the degree of dissociation is 0.4 at 400 Kelvin and 1.0 atm for the gaseous reaction. That is, reaction is PCl5 gives PCl3 plus Cl2. Assuming ideal behavior of all the gases, calculate the density of the equilibrium mixture at 400 Kelvin and 1.0 atm. Okay. Relative atomic mass of phosphorus is 31.0 and of Cl is 35.5. Okay. So first of all, what is given here? First of all, write the reaction. Okay, so here reaction is nothing but PCl5 gives PCl3 plus Cl2. Okay, let us assume initial mole of PCl5 is 1. Okay, so initial mole of PCl5 is nothing but 1. Okay, so what happened? Moles at equilibrium. Let us here assume that is alpha moles is dissociated. Okay, so here the alpha value. Okay, here the degree of dissociation is 0.4. It is given. So here the value of alpha is nothing but 0.4. So here what happens? This 1 minus 0.4 mole is dissociated. So here what happens? 0.4 moles will be formed here also. Okay, now from here we can see that this 1 minus 0.4 is nothing but 0.6. Okay, so now what we will do, we have to calculate the what density of the equilibrium mixture. Okay, density we have to find out. So now if we here what we will do, first of all calculate the total moles at equilibrium. Okay, total moles at equilibrium. So it will be what? The moles of PCl5, okay, moles of PCl3 plus moles of Cl2. Okay, so here the moles of PCl5 is nothing but 0.6, okay, plus 0.4 plus 0.4. Okay, so what happened? It will become 0.6 plus 0.8, which is nothing but 1.4 moles. This is the total moles. Okay, that is N total. Now we know that since it is given that assuming ideal behavior, so according to ideal gas equation, PV is equal to what? nRT. Okay, so what we will do, P is equal to what? N by V RT. Okay, now here the N is nothing but what? That is you know that N is nothing but weight divided by molar mass. Okay, so what we will do, we will substitute, that is pressure is equal to what here? Substitute the value of N, that is weight divided by molar mass, into V here into RT. Okay, now next step will be what? That is P is equal to what? Arrange it like this, that is weight divided by volume. in one place and RT divided by capital M. Okay, capital M is nothing but molar mass. Okay, so what here, that is, we know that density is nothing but that is weight divided by volume. Okay, given mass divided by volume. So here in place of W by V we can substitute D. D is nothing but density. Okay, so we have to find the density, so arrange it. So here density will be what? Density will be what? PM by RT. Okay, so from here the density will be what? That is, it will become that is, the pressure is given is 1 atm into molar mass. Molar mass of PCl5 is nothing but that is 208.5. Okay, so here substitute, that is 208.5. Okay, here the value of R should be what? 0.0821, and temperature is given is nothing but 400 Kelvin. Okay, so what happened? So here what will happen if you multiply? So we will get D is equal to 208.5 divided by that is nothing but 32.8. Okay, so we will get as 6.3567. Okay, now we can here observe that this expression is derived, okay, from here. Okay, so this is the expression. Okay, so here it is the density is nothing for that is for 1 mole. Okay, but we know that here the total mole is 1.4. So we will, what we will do, we will divide by again by 1.4. Okay, so this 6.3567, okay, divided by 1.4. Okay, 1.4. So what we will get? 1.4. So what we will get? Density will be what? 4.54 gram per liter. Okay, so this is the density of the given reaction. Okay, so here we have to just know that this density is derived by taking moles, 1 mole. Okay, but we calculated the mole as 1.4 mole, so we have to divide the final answer by 1.4 so that we get density as 4.54 gram per liter. Okay, so this is the correct answer for the given question. I hope this answers your question. Thank you.